Hi, welcome back. So last time we discussed regarding the type 3, and then we used the technique in type 1 wherein we isolated tangent u, secant u as the derivative of secant. So this time we will use the technique in type 2 wherein we will isolate the secant square u du as the derivative of tangent u, and then we will convert all the secant terms in terms of secant by using its trigonometric identity. Okay, so first let us erase our solution last time. Okay. Yan. So once again, our technique is that we will isolate tangent u, not this one. We'll isolate secant, this one, secant squared u du as the derivative of tangent u. Okay, so by doing that, if we isolate the secant u squared, isolate the secant squared u du, so this will be the derivative of tangent. So what we have left here is that we have secant square here, so we need to multiply one more secant square x. So this is x, by the way, since we use variable x, times tangent cube x, right? So we have tangent cube x secant squared x times secant squared x dx. So okay, so if you want to check, then you can now multiply this term into this term. Okay, so after isolating, since this is the derivative of tangent, so we need to convert all our secant in terms of tangent. So how? Of course, by using the identity that the secant square u is just equal to tangent square u plus 1. So let's copy this one, tangent cube x, then multiply by the identity. We have tangent squared u plus 1, and then multiply by this term, secant squared x dx. By the way, this is x. Okay, and then we will once again multiply this term into this term. So we have tangent cube x times tangent squared x is just 3 plus 2. We have 5x, tangent 5x, and then at the second one we have plus the 1 times tangent cube. We have tangent cube x, then our derivative of tangent u, which is secant squared x d of x. Okay. Once again, as you can see here, you can now distribute the this secant squared x. So we have tangent raised to 5x multiplied by secant squared x dx plus the integral of tangent cube x secant squared x dx, right? That is the second part. Okay, the first part is 1, then the second part is 1. Okay, so after that, we can now use the change of variables. We have to let u is equal to the tangent x, and then the derivative of u is the secant squared x dx, as that is our plan on the first place, right? We need to separate this because the derivative of tangent u is secant square u du. So after that, we can now transform this integrand in terms of u and du. So we have this tangent x raised to 5 here is just equal to u raised to 5, right? So if you are not yet comfortable, then you can rewrite it first by something like this: tangent x raised to 5, then secant squared x dx plus integral of tangent x raised to 3 secant squared x d of x. Okay, then by substituting the value of u, we have this is our u, this is value of u, then we have the integral of u raised to 5, and then our du is equal to secant squared x dx. So we have du, then plus the integral of tangent x once again is our u, so we have u raised to 3, and then this part here is just equal to du. So from here, you can now integrate, which is simply equal to u plus 1 is 6 all over 6 plus u raised to 4 all over 4 plus c, and bringing back the value of u is tangent x. So we have tangent x raised to 6 all over 6 plus tangent x raised to 4 all over 4 plus c. That is now our final answer. Okay, so this part here is our integrand last time. We're using the solution 1, but when we use the solution 2, we come up with this final answer. Okay, so do you think they are equal or they are the same? Okay, so yes, they are the same, but you can now practice to prove if they are equal by simply using the identity. So maybe you can replace the tangent squared x as equal to secant squared x minus 1. Okay, so you try, and then try to prove that this answer here is just equal to our answer on our first solution. Okay, so I end it here. So see you on our next video.